All right, critical review 7 is on radicals. So the opposite operation of applying exponents. So we can undo square root of 4 means we're taking a second root, right? That means the square root of 4 we know it to be 2. That means let me write it this way. The square root of 4 means square root of 4 equals 2 means 2 squared equals 4, right? Because it's a second root. The third root of 8 means 2 to the third is 8, right? So anyways, let's go ahead and evaluate a few here. We have a sixth root of negative 64. So here's the question. If I'm taking a sixth root of negative 64 equals what? That means, let me call the what x for a minute. Let's propose that there's a solution. That means x to the sixth would equal negative 64. Well, what's wrong with that? Yeah, so there's no way that this can happen. We can't go to an even power and get a negative number, right? There's no way we could do that. For example, negative 2 to the 6, that's negative 2 times negative 2 times negative 2 times negative 2. I say that 6 times. Is 64. There's no way it could be negative 64. So this can't happen. You cannot have an even root of a negative number. So this is impossible. Does not exist. Can't have an even root of a negative number. Now we can have an even root of a positive number. That's no problem. What's the fourth root of 81? Well, let's break down 81 into 9 and 9. We know 9 is 3 and 3. The other 9 is 3 and 3. We're looking for 4 of a kind. Fourth root of 81 is 3. There's nothing left over, right? Can we have an odd root of a negative number? You bet. You bet, because something to the third could be negative, right? We could have a negative something to the third power and give you negative 12, right? Well, let's break down 512. 512 is negative 8 times negative 8 times negative 8. So the third root of negative 512, we're looking for 3 of a kind, is negative 8. And let's go ahead. Why don't you guys go ahead and punch that in. Third root of 216. Go ahead, check your work. Third root of 216 is 6. All right, some properties of radicals. Nth root of a to the n is a, as long as n is odd. The nth root of a to the n technically is the absolute value of a if n is even, right? You have the product property of radicals, and you have the quotient property of radicals. Let's go ahead and use some of these. So the ninth root of 10 to the ninth. Well, I think I wrote 9 tens. I'm looking for 9 of a kind. I have 9 tens, so it's just 10, right? Ninth root of 10 to the ninth is just 9. Let's go fifth root of 243 x to the fifth. Well, 243 goes into 3 81 times. So 3 times 81. Then we have 5 x's. And let's keep going with the 81. 81 is 9 and 9. Well, 9 and 9 is 3, 3. The other 9 is 3, 3. I got 5 x's. Looking for 5 of a kind. There's 5 3's. There's 5 x's. So the fifth root of 243 x to the fifth is 3x. Third root of 135 x to the third over 5. I would go ahead and simplify this first. I would go 135 divided by 5 is 27. And then I'd break down the 27. I'm looking for 3 of a kind. So it just ends up with being 3x. Again, let's do a 6th root here. 6th root of 64. Well, 64 is 2 to the 6th. I'm going to write it that way. 2 times 2 times 2 times 2 times 2 times 2. And now I'm going to go ahead and write x to the 12th in packages of 6, if you will. So x squared to the 6th is x to the 12th, right? I'm looking for 6 of kind. So 2 comes out, and then the x squared comes out. And technically, it's actually the absolute value of x. So the property says if the power is even, like the second root of x squared is actually the absolute value of x. So for example, the second root of, let's say, -4 squared. Well, -4 squared, this is not -4. It's the absolute value of -4 is 4, because -4 squared is 16. Square root of 16 is just 4. You with me? So with an even root, technically we should throw on the absolute value. So it's the absolute value of x squared. Well, anytime you square something, it's even. So you can leave the absolute value off here. It really makes no difference because x is being squared anyways. Let's do some more here. I'm looking for 4 of a kind. So I'm going to break down x to the 24th as x to the 6th to the 4th. And then y to the 27th would be y to the 7th to the 4th, right? And so then I'd have x to the 6th, and I should say absolute value of x to the 6th, absolute value of y to the 7th, but they say assume all variables are positive, so we can just leave it as x to the 6th, y to the 7th. In other words, we don't have to be so technical about the absolute value on this. Okay. Let's do this one. 4th root of, I would simplify this. First I have x to the 12th, y to the 29 over x to the 8th, y to the 13th. So let's do 12 x's on the top, 8 on the bottom. I'm left with 4 x's on the top. Now let's do the y's. 29 y's on the top, 13 on the bottom. I'm left with 29 minus 13, 16. Now I'm looking for 4th root. I already have x going to the 4th power, and I'm going to write y to the 4th to the 4th power. So x, y to the 4th. X, y to the 4th on that. Okay. All right, why don't you guys try that one? Go ahead and do that one similarly. Go ahead, check yourself if that work, and let's move on here. Again, we're assuming all variables are positive, so we're not worrying about the absolute value with even roots. But let's look at 256. Let's see, that would be 3rd root 256. 256 is 16 and 16. Let me think about that for a minute. So I have 4 and 4, 4 and 4, and 1, 2, 3, 4 x's. So it looks like I'm looking for 3 of a kind. There's 3, 4. So 4 comes out. I'm looking for 3 of a kind. I have 4 x's. There's 3 right there. So an x comes out, but I'm left over underneath the 3rd root with a 4x. So I can't take a 3rd root of that 4 or the x. So 4x, 3rd root of 4x. Let's do some more like that. Square root of 8x squared times 32x. Notice they're both square roots, so I'm going to put them all underneath the same radical. So I have an 8x squared and a 32x. They're both square roots. So let's think about the 8. and then the 32. Well, 32 is 8 and 4, and then I have x squared and I have x. Here's my x squared, there's my x, and I'm taking a square root. Well, there's 2 of a kind, so 8 comes out, x comes out, and now let's look at the rest of this. I have a 4 and an x, but if I look at the square root of 4, what's the square root of 4? 2. And I'm just left with an x underneath, right? Because I know the square root of 4 is 2. So I have 16x square root of x. 16x square root of x. And technically it's absolute value of x. 16 absolute value of x square root of x, right? All right, I wish we had more time, but I got to kind of move on today. So we got a 5th root here, and then a square root. So 5th root of 81x to the 4th, and then a square root of 9x squared. Now this is, you know what, that's supposed to be a 5th root too. Sorry about that, that's a typo. 5th root of 9x squared, because they both have to be 5th roots to put them both under the radical, and I want this problem to be all 5th roots so I can put them underneath the radical. So we have 5th root, we have an 81, we have a 9, and we have x to the 4th and x squared, so we have 6 x's. I'm looking for 5 of a kind. Let's break 81 down. 81 is 9 and 9, or 3, 3, 3, 3. There's our 81. 9 is 3 and 3, and then we have 6 x's. And I'm looking for 5 of a kind. So a 3 comes out, x comes out, and I'm left over with a 5th root of 3x. Okay. Keep going here, we have 11 times the 3rd root of 9 squared. So we have square root of 11 being squared, we have a 3rd root of 9 being squared. So let's write that. Square root of 11 is square root of 11 times square root of 11, which is just 11. And then 3rd root of 9 squared, so there's another 3rd root of 9. So we have 3rd root of 9 times 9, or 81. Here's 81. I'm looking for 3 of a kind. So 3 comes out, and then I'm left over with a 3rd root of 3. And now we can multiply the 11 and the 3, so we have 33 3rd root of 3. Okay. Nth roots. To simplify nth roots, when you're adding and subtracting, you gotta have like radical terms. That means you have the same root and the same exponent. I'm sorry, the same root and the same index. So like, for example, I said 2 3rd root of 7, I could add to 4 3rd root of 7 because they're both the same root, and underneath the radical is also the same term. So we can add them. So this is 6, 2 plus 4, 6, 2 bananas plus 4 bananas, 6 bananas, 6 bananas, 3rd root of 7s. But you cannot add 3rd root of 7 and 3rd root of 5. This one's got a 7, that one got a 5, so you cannot add them. You just leave it right there. Okay, so you want to go ahead and simplify these and then see if they're like radical terms in order to add them up. So for example, 6 squared of 50. So I'm thinking square root of 50. Well, 50 is 25 and 2. In other words, 5 and 5 and 2. So 5 comes out. So 6 times 5, and I'm left with a 2. So I have 30 root 2. Now let's go to the 2 root 8. Well, 8 is 2, 2, 2. Square root of 4 is 2, so I have a 2 come out. I'm left with a 2 underneath. Now let's deal with the 12. 12 is 4 and 3, 2 and 2 and 3. 2 comes out, I'm left with a 3. So now I'm looking at it and I say, well, which one of these are like radicals? Those two are, they're both square root 2. So 30 root 2 minus 4 root 2, 30 minus 4, 26 root 2 plus 10 root 3. Okay. Let's keep going here. I have 8 third root of 2 square root of 72. Well, 72 is, how was that? 36 and 2. I know the square root of 36 is 6. And then I have this 5 root 32. Well, 32 is 16 and 2. I know the square root of 16 is 4. So I have 8 third root of 2 minus 6 root 2 plus 20 root 2. The only like terms are these two, because they both are square root of 2's, right? The one in front is a third root of 2. That 8 third root of 2, can't combine it. So negative 6 root 2 plus 20 root 2 is 14 root 2. And I still have this 8 third root of 2 as well. Okay, this one is 4 third root of 2 minus 2 third root of 54. So I have, let's break down the 54. 54 is 27 and 2. Well, 27 is 3, 3, 3. So there's 3 of a kind. So I have 4 third root of 2 minus 2 times the 3 that comes out. So minus 6 third root of 2. And notice they're both third root of 2. So 4 third root of 2 minus 6 third root of 2. 4 minus 6 is negative 2 third root of 2. All right, let's keep going. We got 33 third root of 2 minus 9 third root of 128. So let's see, 128 divided by, what is that, 882? Let's see, 64 and 2. Yeah, so that'd be 4 and 4 and 4. There's my 64, there's my 2. Minus the square root of 18. 18 is 9 and 2, so that's square root of 9 is 3. And then square root of 8, that's 4 and 2. So let's see, we got 33 third root of 2 minus 9 times third root of 128. So 4 comes out. 9 times 4, 36 third root of 2 minus 3 square root of 2 plus 5 times 2, 10 root 2. Okay, so these first one, these are like terms. 33 minus 36, those are both third root 2's. So negative 3 third root 2. And then these ones are like terms. Negative 3 root 2 plus 10 root 2 is a 7 root 2. So what I'm going to do here when I'm multiplying, notice the 5 and the 3. I can multiply those on the outside, those real numbers. And then both of them are third root of 4. I have a third root of 4. I have a third root of 14. So I can put those together, the 4 and the 14. Now let me factor 4. 4 is 2 and 2. 14 is 2 and 7. I'm looking for 3 of a kind, so a 2 comes out. And what I'm left with is the third root of 7. So I have 30, 15 times 2, I have 30 third root of 7 on that. Okay. Let's go ahead and multiply and simplify this one, then we'll do one more together. So we're going to go first outer, inner, last, FOIL, inner, last, right? So I have 4th root of 4 times, so I'm doing this one and that one first, right? That's my first. So these two. So there's my first plus, now I'm going to do my outer ones. 4th root of 4 times negative 3 plus, so here's my outer ones. Now let me do my inner ones right there. There's my inner one. So I have a 3 times a 4th root of 4. And then let me do last plus my last 3 times negative 3. Okay? So 4th root of 4 times 4th root of 4. That's 4th root of 16. Well, let me break that down. That's 2, 2, 2, and 2. I have 4 of a kind, so that's 2 plus. Now I'm going to put that negative 3 out front. Negative 3, 4th root of 4. So plus a minus, so I'm going to go minus 3, 4th root of 4. Now I'm looking at my inner one right here. I already have a 3, 4th root of 4. And last I have 3 times negative 3 plus a negative 9. In other words, minus 9. Well, negative 3, 4th root of 4 plus a 3, 4th root of 4, those cancel. So I'm just left with 2 minus 9, which is negative 7. All right, let's finish up this last one and then we'll get you guys started. So 7 root 2 times 3 root 2. There's my first. Outer would be 7 root 2 times the 3. Inner would be 7 times 3 root 2. And last would be 7 times 3. So let's do the first one here. 7 times 3, 21. Square root of 2 times 2 is the square root of 4. Well, square root of 4 is just 2, so I got 42 for the first term. 7 times 3, 21 root 2. Over here I got 7 times 3, 21 root 2. Well, 21 root 2 plus 21 root 2 is 42 root 2. And then lastly I got plus 21. Combine like terms, 42, 21 gives us 63 plus 42 root 2.